So I'm not going to take up a lot of time because by the nature of FameLab, we have an enormous quantity of very talented people from all over the world. And the first three people I'm going to introduce are our panel. I don't know if, for dignity, if you'd like to make your way across the front and across the stage while I explain your role in proceedings. Because FameLab was conceived of by the Cheltenham Science Festival. You could be cynical and say it's because they were starting to run out of scientists who had something interesting to say and could talk to the public, and so they realised they needed a talent search to find new scientists. There's some truth in that. But having started in Cheltenham Science Festival, then the British Council got involved very quickly, and we have an agreement between Cheltenham Science Festival and the British Council to take it out to 20 countries worldwide. And since then also NASA have got involved. So there's an agreement with NASA that they run a FameLab in America, obviously. And what FameLab is essentially a competition. It's been described as Pop Idol for scientists or the X Factor. It's not quite as cruel as any of those things, but it's the same idea. It's can you put your science across very, very quickly? And I think you'll see from the talent this evening that you can. But normally what would happen is we'd have a panel of judges. Their job would be to really put the contestants under pressure and then to decide who's going to win. But this evening, in the more games-like spirit of the Olympics, we're going to hand it over to you guys to decide who gets the gold, silver and bronze medals at the end of the event. But nevertheless, we didn't want you to miss out on the input that a panel of judges has. They're enormously valuable in terms of what they bring to the contestants, and also in terms of kind of being a voice for you, the audience, in asking questions, hopefully the ones that you're thinking of, or some other questions. So we have assembled a really august panel of three people. So go on, process across the front to applause, and then make your way into your seats. And I shall introduce you. I think some of you may in fact know some of our panellists already. We have, from the front, Aoife McLysaght, who, oddly enough, I met only a few weeks ago at the Cheltenham Science Festival, where she was to appear in a radio programme called The Infinite Monkey Cage with Brian Cox and comedian Robin Ince. But most of the time, she's very serious. She's a professor of genetics here at Trinity College and a regular here at the Science Gallery. So you may have seen her before at other events. Also, Jonathan McRae, who's probably a familiar sight to many of you. He presents the Science Squad on RTE1 and Future Proof on News Talk, which with scientific precision, he explained, was Ireland's only national science radio programme. So we don't want any factual heckling on that. But he also writes on science and does a lot of events. And again, he has other events on here at ESOF. And joining them, it's a great pleasure to me to introduce to you Michael White, because he's the director of the British Council in Ireland. But in fact, I first met him when the British Council first got involved in FameLab a number of years ago now, when Michael was the science advisor in London, and decided that FameLab would be a great thing for other British Council countries. And so he was one of the team that introduced FameLab, first of all, to some Southeastern European countries as part of a project called Beautiful Science. And then since then it has spread as far away as Hong Kong and America and all over the world, all sorts of places, some of which you will hear from very shortly. He also said that he did start a physics degree where his supervisor was Brian May, possibly better known as the guitarist of Queen. And I think it's telling that Michael said he didn't finish his physics degree and became more interested in rock and roll. So there you have it. So our esteemed judges are going to not, in fact, decide the winner, but they will listen attentively to each presentation and give the kind of probing feedback that a genuine contestant would get. But now it's my task to introduce to you the first of our 10 FameLab Olympics presenters, each from a different country. So they're all veterans of FameLab in their own countries. They're all part of the international network of FameLabbers. They've all done this before on home turf. There's a couple of differences to the real Olympics, obviously. One of them is that you still have a working public transport system here, unlike London. Another one is, in the Olympics, there's no language barrier, whereas a lot of the people here are not presenting in their first language because they're all going to present to you in English. They're all going to present to you on science, and they're all going to present to you in exactly 3 minutes. And if they overrun, they will hear this noise, and they'll have to stop mid-sentence. So they're under a lot of pressure. So bear that in mind. I want a tense, oppressive atmosphere in the room, ready for... No, I don't. I want lots of love and applause as you welcome to the stage the first presenter this evening, all the way from Bulgaria. He's a vet student. He says he has an interest in crawling things and not just drunk people. All the way from Bulgaria, it's Tomasz Stilyanov.
Hello, let me take you to a journey inside the mind of a 100-meter sprinter, like, for instance, Usain Bolt. Let's see what goes into his mind and what happens there right before he goes and breaks another world record. So, first he goes to the track, thinking stuff like, did I take my lucky shamrock? Or, oh, there's my mom, hey mommy. Then, of course, it's time to concentrate for the 9-point-something sprint. So he concentrates, that takes several minutes. And then it's time for the run. So he starts and then goes left leg, right leg, right leg. Keep the arms moving. And then he crosses the line and it's over. Fine, but wait a second. How does the body know that it's moving and therefore keep the balance? It's not like there is a second computer or brain outside the brain, the body, that is telling him, in that case me, keep moving, keep the balance, you're moving. Actually, that's where the magic begins. Or to be exact, it's the mathematical precision of the brain called reafferentation. What happens is that the eye takes a picture of your current position and through the neuron, which is like the USB cable for the brain, takes that picture to your brain. Then the brain compares that picture with the picture taken thousands of the seconds later. If it finds that the pictures are different, it assumes that you're moving. But then again, how did the brain knows the difference between your body moving and just your eye moving around? It's like with when you're sitting in a train, how do you know that looking at the other train, whether is it the other train moving or it's your train moving? Of course, with the train it's a bit different, so more different details, so ask me later. But both principles of the eye and of the train are found in a distant non-Olympic year of 1954. What happens is that the neuron that takes the picture to the brain is actually the same that commands the movement of the eye. So what the brain does is it calculates the movement of the eye and calculates the movement of the picture. If it finds that the two pictures are different, then it knows we are moving. This principle is used in the most sophisticated gyms, where you have a moving picture inside of your treadmill. So while you're practicing and you have your picture moving, your brain goes thinking that it has to keep the balance. Therefore, you get a better mental workload, which results in a better physical workload, and therefore you get a better workout in the end. But then again, that's still cheating, cheating your body. So my advice is go for the real thing and just go out for a run. Thank you.
So, non-judging judging panel. What feedback or probing questions do you have, Toma?
I thought it was great. It was a great presentation. One question I'd like to ask is, when you say the brain is comparing one image to another, how do we measure something like that?
Well, that's done with a lot of experiments, most of which I know only for animals, because I work with animals. So what they do is they actually put a picture in front of the horse, which they use it, and they make the horse move. And they see that according to all the signals in the brain, they have that huge head with all kind of electric neurons, like USB cables, as I said, running around. And they just picture the whole thing and calculates how much the brain is working, and check the signal that it's sending to the inner ear, which is actually responsible for the balance. Then they start moving the picture around, and they realize that actually moving the picture makes the brain work faster and send more signals. That's how they came to the conclusion, and actually they've proved it that a lot of times by then.
I'm interested in, you chose Usain Bolt as your example. We know that he's really fit and he can run very fast, but does his brain work better at tracking his own motion? And does that, if it does, would that help?
Well, with Usain Bolt, actually, he has one more advantage. That's because he's 194, I think. He has really huge legs. So they're calculated back in the previous Olympics that actually his biggest advantage is that he runs with the same amount of steps as all the other sprinters, but his step is a bit bigger. But then again, his brain still works with the same, does the same calculations as all the other, like Safa Powell, and I forgot who finished third in the previous Olympic.
So you've made the point that the race is less than 10 seconds long. Is it difficult for them to stop at the end?
Well, yeah, it's really difficult. I mean, I know that from my experience, because I play basketball. When I start running towards the basket, and whatever happens, I just have to finish a few meters back because it's really hard to kill all that inertia. But that's because of the muscles, not because of the brain. It's just the muscles start working. You know, they go working and working and moving. They cannot just stop like that. It will be literally suicidal for the muscle if they just stop like that.
And can I say congratulations on your T-shirt? I think that seems to illustrate something about your topic as well. Brilliant. Thank you very much.
Thank you.
They're off to a good start, and it's always much more nerve-wracking to go on first, as we know, but you wouldn't have thought so from watching him. So next up, we have somebody from one of the newer countries to join FameLab. We have a PhD student in chemistry from Vilnius University, and they say little things count, which is good because she works on a project called Nanopinion, which is a European project about what people think about nanotechnology, which, as we all know, is very, very small stuff. I don't know what she's going to talk about this time, though, but please go wild again. Give another huge round of applause. Welcome to the stage, Julia Baniukovic from Lithuania.
Are you waiting for the Olympic Games? Oh, I see the smiles. That's great. Me either, also. So, but in the shadow of the Olympic Games, I guess that we still remember Euro 2012. So, who watched the European Championship? Please raise up your hands. Wow, almost all audience like football. So, that's great. But let's imagine together. Let's imagine the end of the football game. All football players are tired. They're happy or not, it depends on the results. They are sweaty and they're really smelly. So if they will invite you to come closer, I guess that most of the people will say, a little bit later, after your shower. So how can we change this situation? How can we solve this problem? Let's ask the scientists. The scientists created nano socks. But how these nano socks kill bacteria and reduce odor smell? How do it work? People have known about silver antibacterial properties for ages. Even Romans used it to treat the wound. But nowadays, thanks to nanotechnology, a little silver nanoparticles can be embedded in different materials, including fabrics, where they perform their antibacterial effect. So it sounds fantastic, isn't it? So, and according to that, these nasty bags can be killed by released silver ions, which is released from silver nanoparticles, and of course, it can protect young guys' socks, and of course, reduce very bad smell. And due to that, this little nanoparticles are not very toxic to humans. A lot of much more consumables have been developed to use this technology. So it's really fantastic. But we still have no idea how much it is harmful to us and to environment, I believe that it's very good idea to make our world better, to change our world better. And just imagine the fans, the girls' faces after the match. They are happy. So let's enjoy the game. Thank you.
Well, panel.
I thought that was great, actually. I listened to a podcast about this exact same thing not so long ago. Is there any danger with killing a bacteria on the skin that might be good, or killing organisms that are around the areas where we sweat with these silver ions?
No, they are poisonous to bacteria, so that's why they killed that bacteria. But it's not poisonous to our skin and to the people, so it's not. But it can be just what I was talking about, harmful. That there are some experiments what the scientists do. They do on environment when you just wash out the socks, that it can be released some that particles. So, but it in little amount, it's not harmful. It's okay.
So the nanoparticles are embedded in the socks, but when you wash the socks, you lose them.
No.
So does that mean the second time you use the socks, they don't work?
No. You can. They tried, and you can use these socks for several. I don't know for how many times, but really for quite till 10 maybe times, because the biggest amount of these particles can be washed out just during the first time. And later it's not, they are already stuck there. So,
Yeah, so great talk, thank you. It's really loads of fun. So has anybody actually made these socks? Can you buy them or?
Yes, I know that I haven't buy yet for myself. I want it. I know that in Germany you can buy it for sure, because we talked already about that. So I know that some friends from there, they bought already. And you can use that socks for, I guess, for 5 or 6 days, and it won't be any smell.
Oh, wow.
Yes. So.
Yes,
yes, it's something very exciting,
And are they expensive?
I really don't know the price, so I'm not trying to figure out something, but I will check.
Okay.
Thank you.
Thank you.
Thanks very much.
There you are. So anyone in the audience that has smelly feet, you know what you need to do now. Go and buy some silver socks. And on another note, any men in the audience that are developing a beer gut, I have good news for you, because scientists discovered a gene that predisposes some men to have a beer gut. So now if anyone has a go and says cut down the drinking, you just say, no, it's all in my genes. And spilling slightly over the top in some cases. No, but on a more serious note, there are genes that predispose some of us to serious diseases, and our next presenter does research in genes that predispose cardiovascular diseases, which is a much more serious issue. He's from the Czech Republic. He's a postdoctoral researcher at the Center of Biomedical Informatics. So please free your hands up and give another huge round of applause for Jan Kalina.
Hello, I work in bioinformatics. Important? No. I can tell you if you will suffer from a heart failure in the near future. Important? Oh yes. Imagine that you are an Olympic athlete. So, on your marks, get set, go. You run very fast, pushing yourself to the limit. Your heart is under immense stress. Then, suddenly, your heart fails. Why didn't your doctor tell you before the Olympics that this would happen? Let me tell you why. Because a standard heart examination cannot reveal your hidden heart disease. And yet, the genes responsible for the disease are active in your body for several years before the failure. Our research project aims to find out if you have a high risk of a heart failure in the near future. we take blood samples from patients having a heart attack and analyze them using such microarray technology. Well, how to extract the crucial information from this? That's my job. So now you're probably wondering which genes are the lurking monsters that cause the heart to fail. Well, it is very difficult and costly to identify them among the 23,000 genes in your body. So to save money, we use our own simple mathematical approaches to find a diverse set of 10 essential genes. What is that diverse set of genes? Well, it's like the decathlon, a set of 10 diverse disciplines which make very different demands on your body. And so is this set of colorful genes together responsible for a future heart failure. Right now, other scientists are investigating how to turn off the genes that cause your heart to fail. But you all can already use the practical results of our novel method now, believe me. I mean, isn't it wonderful that we can tell you in time that you will die from a heart failure next spring? Thank you.
Well, judging panel.
I work in bioinformatics too. So I won't ask you really hard questions though. No, but that's really great. Thank you. That was really good fun. I really enjoyed that. It was very creative and original approach. And so can you use this then to tell people that really they shouldn't do high intensity sports? You know, so you give the example of the guy running the race at the beginning. So could you tell some people, look, you'll be fine so long as you don't do something too stressful to your heart?
Yes, that was an example in athletics, and it turns out that there exists not only just one kind of a heart disease, but about 40 different diseases which are relevant, especially for athletes. So we believe that at least some of them have some genetic predisposition, so it's possible to copy the same method for different heart diseases as well and use these measurements of gene activities also to predict if a particular person is under a high risk of this disease.
Okay, cool.
So you said there were 23,000 genes in the human body.
Human body.
And how many of them might be implicated in heart failure?
23,000.
23,000. I mean, are you looking for one, or are you looking for 100, or?
Well, it turns out in this work that the set of 10 genes is the optimal.
10.
10 genes, yes, for the heart attack.
You were talking there about the idea of a sprinter, and halfway through the sprint he has a heart attack. But surely the body doesn't need something that stressful. I think I read recently that quite a scary number of heart attacks happen to people while they're on the toilet. Do we need something that drastic to actually cause a heart attack?
Well, the heart attack can be supported by stress, by the sport activity, but not necessarily. So really, the disease can be manifested at any time. And that's because the genetic disposition is pushing the body actually towards the attack, and it can just happen at any time.
Thank you, I really enjoyed it. It was good comic timing actually for the thing.
Okay,
So
thanks.
good.
You'd set your extremely long mathematical equation, would you? Wow, it's the first time I've seen one that actually has to be unrolled on stage. So, our next presenter studied biology and neurobiology He's now creating science learning digital software, so he's gone over more into the computing side, but he apparently did his doctoral research in the interplay of voice and face in human attractiveness, which presumably he's discovered the optimum voice and face thing is to have a small beard, but he's obviously doing something right because he's also expecting a baby. So please welcome from Romania, Silviu Apostol.
Thank you. Have you ever looked at a starry night up there and thought, what if there are some other beings out there? What if they are like us? How could they be? Would they be breathing? Would they be eating? Would they be jogging? Would they have sport? Would they watch other performing sports? What does it take to have sport in a species? Because there is an interplay. You have life and you have sport. You have to have life in order to have sport. There is no sport outside living beings. But is it enough to have life to sport? Life is competition. You've got entities that compete with each other in a limited resource space in order to get copies of themselves, right? So all those copies are not identical, and some of them are different. So you've got different copies, and some are better than the others of reproducing themselves. And you see from this kind of interplay between different kind of entities, you got competition and you got evolution. And you got evolution by natural selection. There is nature, let's say, who selects those entities. And so you've got a key ingredient for sport, that is competition. But is it enough? You can research life, and there's 4 billions of years in which species competed, but there was no species who looked at individuals and let's say support them in their teams, in their sport. So you need something else. You need watching. You need emotions, let's say. What do you need to have this? You need to have a relationship between individuals of that species. For example, in sexually reproducing species, you've got males and females, and they have to choose partners in order to get their offsprings. There's no need for dividing like bacteria. You have to have a partner and produce an offspring. So you are very interested in showing your value to get selected, and you are interested in selecting others who are at least your value on the marketplace, let's say. So you, as an individual who are looking for partners, you have to look and select others. So my bet would be that if we are one day to discover a civilization who has at, let's say, every 4 light years Olympic competitions, there would be a sexually reproducing species with competition and sexual selection. Thank you.
Well, panel, what did you make of that?
I thought it was very interesting, and I've always wondered why species play. There doesn't seem to be, as far as apart from the collaborative effort, there doesn't seem to be an evolutionary reason for playing. Do we know why playing is so important for us, and why cats will play with each other, for example?
One of the hypotheses brought in this was that they are preparing for life, for adult life. Because play is a feature of mostly of young individuals, of puppies and so on. So they are rehearsing the movements of an adult which is preying, let's say. If you see little kittens playing, you could see similar movements with the ones that are done by adult cats catching a mice. So apparently there were selected individuals who let's say, imitate their mother's behavior and use it for playing. This is one of the hypotheses. So the effect is that it's preparing your muscles, your brain, to catch the prey later.
So I like your analogy of evolution and natural selection as sport. But were you basically leading up to then that flirting is sport? Is this does it fulfill the criteria as well of other people like to watch?
It's very related. So my idea it is that it is one of the key ingredients to sport. Sport doesn't rely only on competition and observing others. There's other ingredients, but flirting, it's also encountered in species with sexual reproduction. So it's
the
related.
Courtship.
Once you've got courtship, you've got sport.
Yeah, nice idea. Thanks.
So you said that if evolution is a sport, the end products of evolution are the winners. So that means that we, having evolved to who we are all winners.
Yeah.
Which is rather a nice thought.
Every one of living beings today has an ancestry of winning individuals behind. So yeah, we are the winners, the offspring of the winners of the winners of the winners.
So we can all award ourselves gold medals. That's
Yeah.
a really nice idea. Thank you.
It's the only thing I've ever won.
Thank you.
Thank you.
Thank you very much.
Thank you. What a great message. I think we should all carry each other around, shoulder high. We're the offspring of generations of winners. I also like the idea that flirting could be an Olympic sport for the next Olympics. Finally, something I could be good at. We have got people from many nations in Europe, and the next person up on stage has come all the way from the UK, where she's a PhD student at the University of Oxford. She manages to work across lots of disciplines. She's working with surgeons and engineers and scientists because she's obviously, one discipline wasn't enough for her. She studied biomaterials, so she's managed to get lots of different scientific disciplines in there. Let's see how many she can pack into 3 minutes. All the way from the UK, it's Jenny Tilley.
Talking about shoulder height. That should be better. Okay, so the swimsuit's banned for being the equivalent of steroids, and the double amputee who's deemed to run too fast to compete against able-bodied athletes. What have these stories got in common other than a generally cautious approach to the use of technology in sport? Well, tonight I'm going to use these straws to show you how the application of polymer science to the sporting arena created some of the most controversial sporting stories. Now, polymers are made up of long chains of atoms joined together by strong chemical bonds. And because of energy, they like to arrange themselves in zigzags, with particular angles between their bonds. Now, when I stretch a polymer, I change the angle between the bonds. And the polymer doesn't like that. The polymer wants to return to its original shape. So it provides a restoring force, pulling the material back into its original shape. And it's this spring-like restoring force that the athletes are taking advantage of. Take, for example, the controversial swimsuits. Introduced in 2008, these polymeric swimsuits were designed to be worn 2 sizes too small. So as the athletes squeezed themselves into these tiny suits, hoping for no wardrobe disasters, the suits were compressing their bodies and reducing their drag through the water. So effective were these suits, putting one on could knock seconds off your personal best. And eventually in 2010, they were deemed an unfair advantage and removed from all future competitions. But what's this got to do with our double amputee, Oscar Pistorius? Well, polymers are actually too flexible to be used on their own in legs. It would be like trying to run the 100-meter sprint on pogo sticks. So to increase the strength of this material, scientists introduce carbon fibres. Now, carbon fibres are made up of carbon atoms arranged in lovely hexagons, and this is a very stiff material because you can see whatever direction I pull on these bonds, there are other bonds resisting the deformation. And this produces a very nice material that was so successful in its use in prosthetic limbs that in 2007, Oscar Pistorius ran the 100-meter sprint just over a second slower than Usain Bolt, earning himself a place in the history books, but a ban from competing at the 2008 Olympics. I note, however, that he will be competing this year, so maybe our approach towards technology is as flexible as the polymers that we use. Now, while these materials are controversial in these particular applications, they are used throughout sport. And so I challenge you this summer to see if you can spot the next controversial application of materials science that will make its storming way onto the back pages of our newspapers. Thank you.
Now, judges, what did you think of her material?
Hey.
I'll get the coat.
She's here all week.
Very strong.
I love the science in it. It's good, when you're talking about, polymers, it's sometimes, if you're just using your words, it'd be quite difficult for people to make a visual image. So I think your use of cheap props is very good. How do you feel about the inclusion of sprinters who have their legs chopped off and springs in place? Do you think that we need to have a separate Olympics for those who have been genetically or otherwise improved?
I have to say I've been battling with this in my head for a while now, because I've been going around and telling people that I think it's amazing that a double amputee who lost his legs in a lawnmower accident can run almost as fast as Usain Bolt. And I do think that the achievement and the dedication that goes into that is worthy of an Olympic medal. But the thing is that when Oscar goes home, he takes those legs off and puts on more comfortable legs. And so it's kind of like he's using something that is specifically designed to give him an advantage. Now, I don't know what the science and the biomechanics is and whether it does give him an advantage. There are people who claim it doesn't. But you could say that there's something different going on, and so maybe he should only race against other double amputees. I'm not sure, and I think it's a society issue more than a sport issue.
So what's the difference between having a really good swimsuit and having really good goggles? I mean, they're available to everybody. We can see if you're using it. It's not like drugs and we can't tell. It doesn't feel like cheating to me to have a really good swimsuit.
The thing about the swimsuits was they were ridiculously expensive. And so actually, most people would be lucky if their sponsor bought them one suit. And it took hours to get these things on. And if it split while you were putting it on, not only was it embarrassing, but that was it. Because they didn't wear modesty pants or anything underneath them. They had no other swimsuits with them. And it's so then the rich countries who can afford to buy lots of these suits for their competitors have got a huge advantage just in that, let alone in the extra technology that they can pump in. I think it's all about trying to bring it to a level playing field in terms of money.
So it wasn't really available to everybody then?
No, not really.
One of them did split, didn't it?
Oh, lots. They would split about once a tournament at least. You'd see someone go, ooh, and toddle off stage. They did split a lot. It would take an hour to get them on, using plastic bags to get your feet. In fact, sorry, this is a diversion, but my friend has one of these suits and he's a foot taller than me and he lent it to me. And I thought it'd be really cool to stand here and, while I was talking, put the suit on. I couldn't get it past my knees. And this is a suit that was supposed to be worn by someone a foot taller than me. These things are ridiculous. It's absolutely ridiculous.
What about the circulation? I mean, surely that's important too.
So because it compresses your muscles, it actually reduces muscle fatigue. And they get out of the water after 1,000 meters and say it felt like swimming 100 meters. So it's less about the circulation, more about reducing muscle fatigue, and that was an advantage.
And were these materials had a different original purpose? Because I couldn't imagine that was the original
Polyurethane
intention.
itself is used in running shoes, running tracks. They still wear them in the lycra suits that they're wearing. So it is just generally used. And someone decided it would be brilliant to make swimsuits out of them.
I was going to say, I'm having the horn waved threateningly at me in this instance. Jenny. Fantastic. Well, I hope your brains are warmed up by those ethical dilemmas, because our next presenter is a PhD student not only in logic, but in non-classical logic. So yes, so get those brain cells warmed up, because I think she's going to hit us with something very challenging. And just in case anyone feels inclined to leap up and heckle her non-classical logic and say that doesn't make sense, I'm just going to warn you, she also practices Taekwondo. So sit there and smile. So all the way from Austria, Lara Spendier.
Did you know that watching sports games can lead to rising blood pressure and stress levels? Ukrainian football fans will be able to confirm that after the Euro, when a goal of their team against England was not counted. As a consequence, FIFA finally approved a goal line technology, which electronically determines whether the ball is in the goal or not. I believe this is a first step into the right direction. The same technology is already used in tennis. And have you ever seen a tennis fan stressed out like a football fan? But what do you think? Will we ever be able to use computers as a real decision support for referees? Computers use by default a classical logic, which means they can differentiate between the two truth values 1, true, and 0, false. So strictly regulated things like offside, goals, or even red card fouls, like Zidane's here, are easily decidable for a computer. But how would a computer know when to issue a yellow instead of a red card? Well, this is the point where we logicians come in. We have tools that enable computer to reason about such complex problems. Imagine, for example, the situation of a last man foul, when an obvious goal-scoring opportunity is denied. Such fouls deserve a red card if the goal-scoring opportunity was obvious, and a yellow card if not. But to decide whether this goal-scoring opportunity was obvious or not depends on many factors. For example, how close the attacking player was to the goal, or how easily other defenders could have gained the ball. So we first need a computer to understand vague concepts like close or easy, because classical logic does not suffice here. And this is why we use a so-called fuzzy logic. With fuzzy logics, we do not only restrict ourselves to the two truth values 0 and 1, but can use the whole range of values between 0 and 1 to determine how close or how easy something is. In a second step, we use this fuzzy logic to combine those graded sets of information to get the final result. So we know whether the goal-scoring opportunity was obvious or not. So we logicians are working on our part to provide a logic that is able to reason about one of our complex everyday life problems. In the meantime, other computer scientists are working on their part of the problem, and together we will be able to present an electronic judge as a support for referees in the near future. Then football fans will be less stressed for sure, and England cannot count on referees' mistakes anymore. Thank you.
Well, going for a cheap populist crack there. What do you think, judges?
I find this fascinating area. It was a great presentation. I love this. I don't know if people are aware of Watson, the computer that was programmed to beat the first human in Jeopardy. So they had a big competition and Watson managed to beat it. But there was lots of problems during the performance because, of course, using these logistics, every once in a while Watson would come out with a ridiculous answer, like what is the capital of Greece? And it would say 20-something. And so do you think that every machine is only as good as the people who program it? And so even though we can put in all these statistics and we can work out all these modeling techniques to figure out all the different ways of making sure that the game is fair, you still have a human being making the decision as to what's fair and what's not fair at the time.
Of course, I mean we have to differentiate. I mean, of course, a computer cannot do anything a human has to program it in the end. So it cannot do more than the people who programmed it, but it can be precise. This is the main thing of logic. I mean, we are very precise there. And so those things can be measured very precisely. And then, of course, in the end, a human has to tell which threshold we take in order to, in my example, decide that the goal-scoring opportunity was obvious or not. But in terms of preciseness, I think computers are better than we humans are.
So you have your fuzzy logic, which is saying, so this is different from the 0, 1. I didn't know what fuzzy logic was before, and now I think I understand it, so well done, thank you. But all the computers we have are binary, so they're only dealing with 0s and 1s. So do you have to code your non-classical logic into classical logic? That must be hard.
Yeah, I mean, for every computer program, on the basis there is a logic, which enables the program to reason about these things. So in the end, we have to provide this logic, and put the program on top of it. And then the program is able to use, for example, a fuzzy logic. I mean, of course, in the end, the computer is using binary decisions, but we can implement the logic.
I can see, because I'm not a football fan, so I don't understand your reference to England and Ukraine at all, but they use the same technology in cricket, and I'm a great fan of cricket. And they use, I think, the same technology in cricket as in tennis, where you can see exactly where the ball was going and where it hit the ground. And that the computer can do better than the umpire or the referee, because the camera and the computer can see what's happening. In fuzzy logic, how would you test whether the computer is giving you a better result than the humans in assessing probabilities and nearness to goal and likelihood of a goal and so on?
Well, I mean, in the end, we do not use the fuzzy logic in the end to look at both decisions and decide which one is better. I mean, we can use the computer as a support, the decision of the computer. I mean, for example, like when the ball is in the goal, it's really a binary decision, more or less, because either the ball is in the goal and past the line or not, or either someone is offside or he is not. But in those wake situations, like in the last man foul with the obvious goal scoring opportunity, the computer can give us an input of what in this precise mold would be the right decision. And then in the end, we can see how this goes with football, if they approve of such a thing.
We could have used that in the game against France to qualify for the World Cup, so unfortunately you're a little too late.
Austria could need something like that as well.
Thank you.
Thank you very much.
There's obviously going to be lots of demand for these robot referees as soon as they bring them in. Although then you'll just have a different lot of countries unhappy. So you really can't win. We may be hearing about some more computer technology next, because our next presenter studies electrical and computer engineering at Cyprus University of Technology. And he's researching something to do with multi-touch surfaces, whatever they are. We may hear about them, I don't know. But either way, please muster yourselves, give a big round of applause. Welcome to the stage, all the way from Cyprus, Marios Iziakidis.
Have you ever wondered why some balls can bounce while others hit the ground like a watermelon? I mean, let's take, for example, a basketball. You can play with it, and then it comes back in your hand. Now let's take a bowling ball. Ooh. Leave it from a height, and it will stay in the ground still. They have the same shape, and size doesn't seem to make any difference, right? So why life treats them so differently? At first, I think we should understand what's happening when the ball hits the ground. We have an impact, a collision. And although the collision lasts only for a short time, it is ruled by two of the most important principles in physics. First, energy cannot be destroyed, neither can be created. And this leads to another law, the third law of Newton in physics, the law of action and reaction. When the ball hits the ground pushes back the ball with exactly the same way, same force, just opposite direction. And this pull is enough to push the ball back in the air. When the objects that collide behave like the basketball and the ground, we have an elastic collision. But when they act like the bowling ball and the ground, we are having an inelastic collision. So the same phenomenon is happening. Why do we have this difference? The key word, elasticity. The basketball is made to be elastic, is made to jump. It's filled up with air and it's made out of plastic. The bowling ball, on the other side, it is made out of a hard material, so it will hit with strength when we're striking. Collisions are happening everywhere around us, and they're very important. Every one of us is here because of a collision between our parent and our mother, right? And in sports, they are very important too. I mean, the air is pushing the sailboat's sail so it can go forward. And if it wasn't for collisions, footballers wouldn't be able to kick the ball and wouldn't be able to score for their team. And never to forget the martial arts fighters. The martial art fighter feels the same force in his hand that the opponent feels in his head. Now, I believe after that now we can all understand why collisions are so important for sports. And I believe that if Newton was alive today, he would insist on renaming FameLab Olympics to FameLab Colympics, since even the slightest collision can determine the winner from the loser. Thank you.
Science and a pun. Well, judges.
So, Marius, I really liked the way you dispensed with audiovisual aids. Some people have come up with straws and rolls of paper, but you had imaginary balls, and I could see it jumping. So I think that was really nice. Congratulations on managing, without any props at all, to convey the essence of what you were talking about. That's a really important thing to be able to do, I think.
It would be difficult to bring the balls with me. Especially the bowling ball.
I think you might not get thanked by the venue if you leave holes in the floor.
So that was it was really nice. How did you come up with the idea of coming up with kind of, I suppose, the classical physics talk? It's different from what you normally do, right?
I like classic physics, and I think that they are very important in sports. It's happening in the background, but still, if it wasn't for it, and it helps understand on how we can get better in sports with this.
And so should synchronized swimming be excluded? No collisions.
I mean, if your hand didn't have a collision with water, you would not be able to go ahead.
So there we go.
How important is that sort of a basic approach to physics? I mean, in terms of materials in sport, dealing with collisions, is that important? The type of materials that people are wearing to prevent themselves from getting damaged from collision?
Yeah, as we said that the elasticity of especially for collisions, elasticity is a very important factor. I mean, one would not go to swim with a silver swimming suit. It would not help him. But in terms of collision, football is not made out of concrete. It's made out of I think.
Thanks very much. That was great.
Great, thank you.
Thank you very much. Yeah, they probably are quite relieved you didn't drop a bowling ball through the floor. No smiles at all from the venue on that one. Right, so we only have two presenters to go.
3.
That's the right response. So our next presenter is also from the physics department. She's from the physics department of the University of Athens. But she's done... Oh, I'm sorry. That's deducting points for me. No, I skipped ahead. We've only got 3 presenters left. Yeah, that's more like it. Good. That's why I'm studying maths in my spare time. Well, how many in 10 again? Yes, so our next presenter did a master's in sports science and is the executive director of the Research Centre for Human Movement Sciences. So he should at least be able to find his way onto the stage better than I can count. He's finishing his PhD, and he has his viva this week. I don't know whether he's already had it or no. Friday.
Wow.
Friday. So this is as nothing to him because he's going to fly back to Portugal and do his viva for his PhD. But nonetheless, give him an encouraging welcome. It's Pedro Moroz.
Well, thank you, and hello everyone. First of all, apologize my bad English. That's why I got this T-shirt, so that you at least handle with that. And first of all, I have to tell you that my girlfriend is an Olympic athlete. And so some time ago, we were having dinner, and she asked me, Pedro, how can I be successful in London? And I told her, well, there are 2 ways, the right way and the wrong way. For the right way, you have to pay me, because I make research in sports sciences, so I can evaluate you in biomechanical way, physiology, and try to figure out how to improve your performance. But if you don't want to pay me, you can go the wrong way, that is, use drugs. Yeah, you already talked about drugs today, about the ethics and everything, but it's a more common practice than we think. For instance, did you know that 800 years BC, men used to eat testicle of lambs, not of themselves, of course, but they felt powerful, and they can throw further, they could run faster. And why was that? It was because the high levels of testosterone. Well, testosterone is a hormone that all of us have it, and it is the main responsible for our sexual desire. Some of us have it, some of us doesn't have it so much. For the hair growth, for muscle hypertrophy, for the bone density. And indeed, all of us have it, but the men have a daily production 20 times greater than women. And I'm glad with that, because I don't like women with mustache very much. Indeed, what does happen? Well, the muscle cell is not like the other cells in our own human body. It is a very long and thin cell, and it is mainly constituted by proteins. Proteins that are like this, and every time you make a muscle contraction, the movement occurs like this. And if you work very hard, you make exercise, the proteins will damage. And so they need to be fixed, and then it's when testosterone goes into your cell to find with the androgen receptors, and then make the resynthesis of that protein to make it bigger and stronger. And so, if you want to have bigger and stronger muscles, you may take testosterone. Although I do think that it's not right, because it's unethical and it's not so good for me for making evaluation of athletes, it's true. And I do believe that all of you know that doping is bad, right? Everyone? No. But I bet that all of you are fans of Asterix, yeah? With the magic potion. Isn't that doping? So, the truth and the real message for all the athletes, and I guess for everyone in our life, is that to be successful in anything, we just have to do the best we can. As a lady said, we are not obligated to win. We just are obligated to keep trying every day. Thank you.
Well, panel?
So in your work, you say you're evaluating athletes. Can you tell if somebody is doping, or would you have a suspicion?
No. I just make the evaluation of those that don't take drugs.
Okay, but if somebody was, would you be able to tell in the kind of work you do, or you wouldn't be able to tell the difference between somebody who's just...
No, I trust on well, there are several departments. Well, I do the physics and physiology analysis. I trust on the doctors that they are truth to me, and they make that analysis of urine, and they say if he is using substances or is not. And I know that in Portugal there was a case in an athlete that paid something to that guy, and so he didn't find it out. So it's a weird stuff, but yeah.
So, and what kind of things then do you look for when you are?
Well, for instance, I don't have a girlfriend that she's Olympic, but let's imagine that it was a shot put.
You lied to us.
No, I have. She just dumped me last week. But the truth is that, for instance, a thrower, a shot put thrower, it's about 1.5 seconds of movement. So they practice for 4 years to get a chance to, in 1 second, do everything they can. And so what I do the movement analysis of that, trying to get out how to increase the velocity, because it's always related with power, because there has to be a very big balance between force and velocity, so that power can be the maximum, and then try to figure out how to throw it the further she can. For swimmers, for instance, it's just swim a distance the fastest you can. It's easy.
Can you give people then kind of scientifically based advice on the shot put, etc.? Okay, that's great.
I use a lot of cameras, I digitize them, it's a lot of computer work, etc. But yeah, that's the idea.
Very nice.
It's a very topical subject at the moment, not just because of the Olympics, but Lance Armstrong is strenuously defending himself against pretty much anyone he's ever worked with who've all said, you've been taking drugs. Is the Olympics then not the graceful series of games that we imagine it to be? But is it not just a comparison as to who has the most productive testosterone glands? Is it just down to the biology that's inside someone, or is there more than just testosterone to show who's better at performing?
Yeah, well, I think that sports and performance is obviously a balance between many factors. Like genetics, of course, is very important. Then the technique that is used, the physiology or the biology to get the energy. And for that, even the environment is also important. And yes, the concentrations of testosterone might be important for someone who wants to be a weightlifter. Probably you look at me and you think, that guy will never swim besides Michael Phelps. But maybe I have more testosterone than he does. So it has a many factors dependency to increase your performance. Okay, thank you.
Like people.
Well, that's testosterone. This sport flirting thing does keep coming up. And as somebody who went to college with a lot of PE students, I find that very worrying. So now we do have the person I was trying to introduce before. I'm sorry about that. It's entirely my fault. So I hope you've been able to contain your excitement, because now you are getting someone from the physics department of the University of Athens.
Yay!
Exactly. And she's also done a lot of work, not only with FameLab, but now she's been helping in Greece with something they're trying called School Lab, which is kind of a similar thing for school-aged kids. So she's really got the FameLab spirit. So go crazy and welcome onto the stage from Greece, obviously, Anna Christodoulou.
Okay, hello everyone. As I'm sure you might all know, we hosted the Olympics in Athens 8 years ago. So I thought it was a great idea to take my little nephew and go and watch the games. I was super excited and ready to cheer at any moment, and he was super busy pulling my shirt like that and asking questions. Why are the runners assuming such a funny position? Why are the cyclists wearing so tight clothes? Why? Wait, here. There is a nice lollipop for you. There you go. Happily, the lollipop did the trick, but I also promised him that I would look his questions up and come back to him. And that's exactly what I did, and I wasn't surprised to find that physics was hiding behind all his questions. Physics is everywhere after all, and in this case, physics is in the air. I'm talking, of course, about aerodynamics. Aerodynamics is the study of the forces and the resulting motion of an object in the air. It's the reason why a paper airplane flies while a paper sheet doesn't. It's all about fighting the air resistance when trying to accelerate in high speed. You see, if you're moving this way, then the air resistance will push you the other way around, resisting to your motion. And what can you do about this? You can create a great aerodynamic shape. How? 2 ways: curves and angles. Let's just say that this is an air molecule. If it comes and hits you vertically, it has no other choice but to push you back. But if it meets a curve, it slides. And if it meets an angle, it bounces off. And maybe this is not that important when you're just walking, but if it is the 100-meter race we're talking about, then it does make a difference. And this is why, back in 1896, Thomas Berg won in the first modern Olympic Games, the 100-meter race. You see, at the time, the runners started running standing upright like I am right now. But he was the very first to assume the crouching position, a much more aerodynamic one. And maybe he was looking a little funny being the only one doing it, but when he did the 100 meters in 12 seconds, no one was laughing at him anymore. And the same applies to cycling. And this is why the cyclists are always wearing their aerodynamic helmets and tight clothes. And this is why my brother was advised when he started cycling to cut his long, fluffy hair. So the next time I went to my nephew, it was a blast. I answered all his questions, and then he interrupted me and said, "Can I ask you one more thing, please?" "Sure, go on. I'm perfectly prepared for anything you might ask." "Did you bring me any lollipop today?" Anything but for that. Thank you so much for listening to me tonight. And to all of you getting ready for the Olympics, I salute you there.
That's really well done. Your nephew's very lucky to have such a thorough auntie.
Well, he has 2 brothers now. I bring lollipops to all of them.
Okay. Does he like appreciate the physics as much as the lollipop? I hope.
Hopefully, I hope so.
You'll have to get into glucose metabolism as your next lecture, I think. But that was really, really nice, really good. So I really enjoyed that. Thank you.
Thank you so much.
So my question is, you mentioned the cyclists who wear helmets and aerodynamic, and I guess their costumes also and their bicycles are designed to give least resistance. And it's okay for them, but it wasn't okay for the swimmers to wear those very special swimsuits.
Well, I'm supposing that it didn't have to do so much with hydrodynamics. Of course, it must have been playing a huge role, but it must have been about this material that would try to get its shape back and force them a little forward, maybe.
I have a question. Is the crouching position for a sprint, is the benefit not more that you have potential energy in your legs when they're bent
It is
and that pushes you forward? Is that not more than the
Nowadays,
aerodynamics?
they also have standing these stands that they can force you, and you can have the bullet starting, but it does have to do with the crouching position and the aerodynamic as well, because if you start upright, then you give a much bigger target for the air to hit vertically on. If you start in the crouching position, you don't.
So would it be better to run on all 4s?
Well, that might cause some difficulties because you're not used to.
Well, there's a guy who, I read about this, the Guinness World Records is 20 seconds on all 4s, which is 10 seconds over Usain Bolt. 20 seconds on all 4s. He copied, I think, monkeys in Asia. It's actually an amazing thing to watch. But there you go, there's a bit of weird fact for you. 20 seconds on all 4s, 100 meters. There you go. That's me.
We should have a new event then, shouldn't we? The all 4s 100
They should have a separate Olympics for the, Oscar, the people on all 4s, and anyone who wants to take note.
All sorts of variations.
The dodgy Olympics. That was great. Thank you very much.
Thank you. Thank you too.
It's really the judges to planning their alternative Olympics. Is it this microphone that's playing up? No, it's mine. No. Good, it's you. It's one of you. Stop it. Whatever it is you're doing, stop it. Okay. So, are you ready for the last contestant? Go on, you can do better than that. Are you ready for the last contestant?
Yeah!
That's more like it. You can't penalise him for being 10th out of 10. He's just finished a master's degree in astrophysics. He does sport, things like sailing, hiking and climbing. He's come all the way from Poland, and his name is Janek Major.
Welcome, everybody. Let's begin with a question. Maybe silly one, but what do you think? When the wind is blowing, it can push things or pull them? Who is for pushing? Okay. And for pulling? I see we have a few sailors with us today. Okay, wind can do both. Of course, pushing is very simple, like this, so I won't say much about this, but pulling. How can we trigger wind to pull something in opposite direction? How is it even possible? Because it is. If it wasn't, we wouldn't have great geographical discoveries, planes, nor sports like sailing, windsurfing, or even parachuting. How it's possible? But maybe I don't think you believe me, so maybe before I start talking, I will just show you. Here we have, say, pirate's ship. Here is treasure. And wind is blowing from here. So will they have to go all the way around the Earth to come here, or they can take shortcut? Let's see. They are trying. It's not so easy, sailing. So
So they have fallen from the edge of the earth, but thanks to them, now we can believe it's possible. Wind can pull something into its direction. But still, how? Because the sail, it's not mere piece of fabric. It has shape, it's bent. And because of that, it acts like a wing. When the wind is coming here, it cuts it into two streams. And this stream, because of this shape, have to go much faster. And when the air is going faster, it has less pressure. So you see, we have pressure here and higher pressure here. So there is a force acting here, and it moves our boat into its direction. And, basing on this very simple observation, only with the board and the sail, we can go anywhere, we can go against the wind, we can go faster than wind even. Thank you.
Well, having congratulated Marios on his imaginary props, I have to congratulate you on your props, which really demonstrated the effect very well. I think that was lovely.
Yeah, I thought, no one will believe me when I just say the boat can move in this direction.
So you showed that it can, which is really good. Great.
Very good principle of the scientist. Demonstrate something with evidence. Thank you. But I was thinking about this, like when you were saying this, though, people designed sails probably based on trial and error, and then later we had the physics to explain what was happening.
Yeah, of course, we have sails from like thousands of years, and it's called Bernoulli law. I can use this term, and it's from, I think, 2 or 3 centuries ago. So,
when they finally understood what was happening. Okay.
It's usually like we use something, and after this we understood how it works.
Yeah, I get my dad to explain this to me every year. He's a pilot, and I go, "How does the plane work again?" And he goes, "It's the pressure." Just look it up on YouTube. Thank you for reminding me.
But then, why can a plane fly upside down? And they can, right?
Yeah. Sometimes planes can fly upside down, but this is a slightly different condition, because boat moves exactly because of this force, because these sails have like this bended shape, and when we have engines and the plane is already moving fast, in fact, its movement creates difference of pressures. And it's something like this. It's a bit different.
So you don't do it slow, do you? You don't fly a plane upside down slow?
It's quite dangerous, I think.
Not good, yeah.
Thank you. Good tips for the weekend.
Now, if you take away nothing else from this evening, important tip: do not fly a plane upside down slow. Okay, I don't want to hear of anyone trying that out. Now, this is where things get complicated. So we've got a number of things going to happen. The first is going to happen is that our fantastic panel of judges, if they were real judges, if this was a FameLab competition, they would be quaking their boots now, because they would have to go out and decide which of those 10 people was going to win, was going to be a runner-up, based on who had the best content, who spoke with the most clarity, who had the most charisma, and they would be locked in a room arguing for the next 20 minutes. But luckily, they get a night off. So having given all that lovely feedback on those questions, their work is almost done. Michael, I think, is going to come back and award the medals. So I'd like you to give them a huge round of applause as they go off and relax. Yeah, clear off. Because we're going to get all 10 of the contestants up on stage now. We're going to need all the room we've got. What happens now is it's time for you people to do some work. You have your voting slips, I hope. Hope you haven't made them into aeroplanes now. You have your voting slips. We're going to get all 10 contestants up on stage to remind you who was who. You have your sheets with the photos so you know who they are. In fact, the photos are on the voting sheets, aren't they? So they're all going to come on stage. You're going to give them another round of applause. Then you're going to vote. Liz, I think, who's at the back. There are people. Mysterious people. No, people wearing Science Gallery T-shirts will collect your votes. So first of all, please, let's have you all up on stage again, all 10 contestants. You have to form yourself into some kind of human pyramid, I think, to fit you all on. In no particular order, here we are. Go on. you all fit in one line? Nearly. Maybe you have to form two lines of people front kneeling down like a football team. Yeah, very good. You say which ones are a football team. Excellent. So they are. Give them another round of applause. These are the 10 people. You need to vote. I haven't actually checked this voting system. Is it one vote? It's one vote. You have one vote. One vote. You put it in one of the boxes. And then we're going to count the votes and see who wins the bronze, silver and gold medals. And this isn't an EU project, so we're not going to keep coming back till you give us the right answer. So, another round of applause. Leave the stage again, contestants. No, it's just one tick. It's all very simple. How to keep it basic. It's a binary system. It's tick or no tick. Even I can understand that. No fuzzy logic here. No, it's all good old-fashioned classical logic. Now, while you're doing that, we thought it'd be interesting to hear from someone else who is a FameLab veteran, who's not in the contest, so we can have a bit more of a relaxed chat about the whole FameLab process from the contestant's point of view. Are you microphoned up, or are you going to be using this one? You're going to be using this one. Good, okay. So, our next person on stage, who's not a contestant, who's more of a guest, graduated in digital media engineering from the German University in Cairo. He's working as a 3D artist now, mainly animation 3D graphics. He took part in FameLab Egypt last year in 2011, which, as you may have noticed, was kind of a hectic year for Egypt, quite an exciting time. But nevertheless, he found time to be a finalist in FameLab with a presentation on a brain gate, which is a very exciting thing where you have a chip in your brain that you could use to control a prosthetic limb. But we said to him, could you do something sport-related for us this evening? So what's going to happen is he's going to come and do his 3-minute presentation for us. And then we're going to have a little chat to him about the whole FameLab process and how it works. So imagine for a moment that this is indeed another FameLab presentation. And welcome to the stage, the round of applause, Karim Helmi. Now I'm going to sit here and pretend to be Josh. There you go.
Good afternoon. Well, the Olympics are approaching, and I'm sure we are all amazed when we see the ice skating games with all the movements they do. Let's take a couple of seconds and think about the movement of the gold medalist single man competition when he jumps and takes off from the ice with a speed approximately 20 meters per hour, then makes 4 spins in the air and then lands on one leg just to complete his performance. If we try to do it ourselves, I will stand here and then I will jump. Barely I did one spin, not 4. So this is not away from physics because it applies the concept of the conservation of the angular momentum. So first of all, this law states that the angular momentum can be conserved as long as there is no external forces acting upon the object. So what is the momentum? It's the tendency of the object to remain moving, and it's depending on the mass and the velocity of the object. So accordingly, for the angular velocity, the equation will be h equal iw. The I is the inertia, but we will consider it here as it plays the role of the mass of the object. And the w is the velocity, but with the angular velocity, which is the object turning in circles. So that is the angular momentum. So in order to know more, let's try to do this experiment, and maybe you can do it at home. I'm going to sit here. I hope I won't fall off. And I'm going to spin. Oh. Spin, then make my hand here. I could spin forever. Because if we neglect the friction of the chair, so the angular momentum will be constant. So the only variables are the mass and the velocity. So what happened that I gained actually velocity when I lowered down my hands, and On the opposite side, I moved slowly when I raised my hands. Why? Because when I raised my hands, I made a change to the total mass of my body, which is increased, and then there is a decrease in the velocity. And on the opposite side, when I put back down my arms, my mass decreased, and then the velocity increased. And that is applied also to ice skaters, because there is no friction, or we can neglect the friction between the ice and the skate, so they can like turn for a very long time with no stopping. And then when they do the force and they jump up in the air, they tend to jump with their hands stretched away, and then in the air they put it down so they can gain speed in the air, and then after that accordingly they can do more spins in the air. So next Olympics you must watch closely and observe their movements, and if you want to try it at home you can do it, but I'm not sure about, or I'm not responsible about the injuries you can have. Thank you.
Thank you, Karim.
Thank you.
So you've now done several FameLab presentations. You did 2 in Egypt?
3.
3 in Egypt, so 2 at the regional round and 1 at the national final?
No, I mean 2 in the qualification round and then 1 at the final
and
of
1 at the
Egypt.
final. So you've been through that whole process, and now this is a new presentation that you wrote for today. So can you tell us briefly, 3 minutes is a very short time to get a subject across. What's the first thing you do when you're preparing your FameLab presentation?
Okay, first thing I personally do that I choose a topic that is not related to my field of studies or my field of work.
Why do you do that?
Because actually I find it's one of the main reasons we have FameLab, because you can talk or you can like deliver an information about any scientific concept or phenomena. It's not just you must be working in that field, so you can just spread science through any means. So the first thing I search for different topics that I don't know anything about it, and then I try to understand, and then I pick up the main points in that concept, so I can deliver. Of course, 3 minutes you can't deliver the whole thing, but you pick the main thing that you can deliver the info. And then I tries to like say the presentation to someone who has absolutely no background, no scientific background. So if he understands, then the info is delivered.
Do you have one person who you always go back to every time with your presentation?
Usually my friends.
Just your friends,
yeah.
Generally.
Yeah.
So you talk through with your friends. Do you write out your presentation word for word, or do you just?
Yep. No, I just write the main ideas that I will be talking about, and then I start to a little bit rehearse and recite about 159 times in order,
give or take 2,
in order to make sure that I'm following the main ideas, because usually it's like a chain. If an idea dropped in the middle, it will be a little bit of a problem to complete for the 3 minutes.
So you didn't really use any props for this. Have you used props before?
Yeah, I used the props in the finals in Egypt, because I was talking about the brain. So I had this.
You had a brain.
Yeah. No. Actually, I had a ball, and I just like made two halves of the ball to be like the right hand, the right brain and the left brain. And the next time I will get a real brain to be more realistic.
I don't know. I think there's some ethical issues there. Yeah. Okay, so sometimes you use props, sometimes not, depending. Well, I suppose you used yourself as a prop.
Yes.
Do you think it adds something to do a demonstration? Because we saw this afternoon some people just speak, some people use props or pictures.
Well, I think it's according to the content of your presentation, because maybe if you have a topic and you use a prop, you will like it will be with no need. So it will be an extra. You don't need it. You know what I mean? But if it really needs a prop that you will deliver a message, I believe it will add a lot.
So not for the sake of it.
No, it's not like you must use props.
What did you learn from doing your very first presentation to to today, say? What did you learn? What things did you do and you thought, well, I'm not going to do that again, or?
Nothing.
Has FameLab changed your life?
Nothing, no. I'm just kidding. For sure, from the very first presentation till that one, there is some progress at choosing what to say and what not to say, according to importance and according to a priority of the topic. So that's why I'm trying to focus more about the real message we want to deliver, and then after that, maybe anyone can do more search to know more about the topic.
So they've got simpler since the first one.
Yes, for sure,
Yeah.
sure. Yeah, I think in the first one, I think I was like 3 minutes exactly. Yeah, in the very first one, because I had a lot of info to say.
You're talking very quickly.
Yeah.
Why did you first enter FameLab? Because Egypt last year, plenty of things going on. It's not like you would have been sitting in Cairo being bored. What was it that made you want to enter FameLab last year?
Well, in Egypt, the situation is really nice, and we love to enter competitions, and we love to play. No, actually, after the revolution, it became like more important to have the idea of spreading science, or the idea of science communication, because we are about to build what we call the new Egypt after the revolution. So we cannot build the new Egypt without having basic info about science. I know not all the people will become doctors, engineers, and scientists, but at least they must have the background about different concepts, and that will make them like go on with their life more easier and more better. But to be really frankly speaking, for myself, at first I know about FameLab by total coincidence, and I was like sitting with one of my friends, and he said, okay, you can present, why don't you go to the competition FameLab? At first I thought, okay, I will go, that's just to present and to have the experience of being in front of an audience and so on. But after I read and I knew the real FameLab idea, I got more attached to it.
Oh, good. That's very good. We're doing something right, obviously. Yeah. And have you been doing things since last year's FameLab? Obviously, you're here in Dublin, City of Science, at the ESOF Festival, which is great. Have you been doing other things? Are you still giving presentations? Well,
I had another experience with FameLab, that I moderated the FameLab 2012. Like, I was standing in your position, and then it was amazing because I got to listen to like 100 presentations throughout the qualifications and then final rounds. So I got a lot of info and a lot of interesting info. Plus, I joined some other activities. I mean, with my university and other stuff like that. And then finally, I'm here in Dublin.
So it has changed your life a little bit.
Yeah, for sure. And there is an impact on my. Oh yeah, there is no impact. I will not say it. No, there is an impact, especially on my personality. Like, as I told you, it's indirectly put you in the position that you get the most important info from different aspects. I don't mean now science only. Well, I mean, if you are in facing any any topic, you can just grasp the more important info and then try to know more about that. So. And for sure, it gave me a lot of more of confidence in was talking with people and stuff like that after presenting in front of different audience every time.
Well, it must be. If you've compared for 100 other contestants, you must be pretty relaxed by now. How are we doing on the audience vote? Oh, we have the results of the audience vote. So, Karim, thank you very much. Thank you for sharing that with us.
Thank you.
So let's welcome back to the stage Michael White. Oh, you're going to make me read the results out. Okay.
In reverse order.
In reverse order, yes. I may not watch sport, but I know how medals work. And you're going to pin them on.
This is bronze.
I'm sorry we haven't got the stand things and so forth. I know we haven't got the podium. Get them to crouch. Yes. The bronze one should kneel down. The silver one should squat slightly. That wouldn't be at all demeaning, would it? No. Great. Okay, so in reverse order. I also asked about the national anthems, but then somebody coughed and suggested that if the UK person won, that might get a bit embarrassing all round. So we're not doing that. I think in the absence of music, I'd like you to drum your feet gently on the floor in a drum roll of anticipation. And please welcome to the stage to receive the bronze medal. It's Anna Christodoulou from Greece.
So, let me put this on you. Congratulations and very well done.
Thank you. Thank you so much, everyone.
I wish we had a lollipop to give you as well.
But do stay here. Do stay here on the stage so that we can...
So
well done. Well done.
Nice time.
Thank you.
Stay over here and then we can get all three of you together, all three medal winners. Okay? Ready for a slightly bigger drum roll of anticipation. So welcome to stage the silver medal winner, Jenny Tilley from the UK.
Congratulations, well done. Put that on you.
Oh, thank you very much.
And it's not plastic, it's not a polymer.
Is it real silver?
Oh, yes.
Well, that'll be handy for killing bacteria later then.
Yeah, keep your socks smelling good.
Oh, it's all getting personal now. And finally, I'm going to have to get off the stage, it's too small. Yes, the man we've all been waiting for. Give a hum of anticipation. It's the gold medal winner, all the way from the Czech Republic. It's Jan Kalila.
Congratulations, very well done. There we go. Don't get heart failure just at this moment, will you? There's you. Well done. Please.
Go on, arrange yourselves in the gold, silver, bronze. Anybody know which side silver goes? Point if you do. Yes, that's it, good. I'm glad you three know what you're doing. So here we have, from the FameLab Olympics, specially for you, Dublin, City of Science, our gold, silver and bronze medal winners. Would you like to say a few words as the gold medal winner, Jan?
Well, I would like to thank you for coming, and I'm happy that this event could take part, and I would like to thank also the organizers for creating a nice environment for us.
Beautifully spoken. Thank you very much. So, I'm afraid we are slightly running over time, so we're not going to carry on with any more large speeches. I would like to echo Jan's message and thank all the organisers and the Science Gallery here for welcoming us and making it such a lovely event. And of course, Michael on behalf of the British Council, for the British Council's part. And Liz, who actually secretly has been doing a lot of the work behind the scenes. And of course, not only Kareem, our exhibition presenter, wherever he's gone, but also our 10 contestants in the FameLab Olympics. Please give them a huge round of applause to finish off.